everybody. In this video we are going to talk about one of the cool options in Excel, and actually it's a very time-saving option. We discussed it later, but we didn't go into details, earlier, but we didn't go in details in previous videos, especially the video of the matrices. And actually matrices is a special case of the arrays, and in this video I'm gonna be focusing more on the general array calculation thing. So to remind everybody about the arrays is simply calculations that are relating set of data with another set of data. To make it clear, I'm gonna just discuss it first on this example that we see here. So in this example we have two sets of data, A and B, A1, 2, 3 till 8, and then this 7, 8 till 57. These are just random numbers. And in this case we need to calculate the sum of the multiplication of each two corresponding values of A and B, meaning that I want to multiply 1 by 7, 2 by 8, 3 by 9, and so on till 8 by 57, and then the sum of these values is the final value that I want to get. So if anybody is thinking how he's gonna or she's gonna solve it, is simply I'm gonna make another row here, multiply A by B for each cell, for each data point, and then we have all these values calculated, and at the end I'm gonna calculate the sum as you see here. And this is actually the final value that I want. So to do this we did one step to calculate the multiplication of the first, and then drag to calculate the multiplication of each in cell in the series, and then the third step is to do the addition. Actually we can do this in an easier way or a quicker way using the array calculation. So I'm gonna show you this in two steps. The first is to do the calculation of all these values in just one step instead of calculating and then dragging. So I'll do here A multiplied by B and say arrays, and the same way we did when we we're doing the matrix calculations, we will just highlight the cells that I want the answer to be showing in. I'm sorry. And then write the formula, but in this case instead of having cell multiplied by cell, I will have these data with these data, and then don't forget to press Ctrl Shift and Enter, and here we go. It's exactly the same values. You did this in just single step instead of doing this and then dragging, and then you will do the summation as you did here, so you have the same values, of course. Arrays can be even more effective by reducing the number of steps to only one step, and this is by doing the multiplication and the addition in one step. And this will be helpful in a case like this where I'm not interested in these values. Actually I don't want to know what is the multiplication of 8 by 57 or 7 by 35. I want to calculate the sum of the multiplication, so these intermediate values are not of interest to me. So I can do the same thing that I did last time, but instead of just calculating all the values, I will calculate the sum of these values. So I'm gonna ask Excel to get the sum of the the multiplication of these two set of data, and again press Ctrl Shift and Enter, and here we go. So it's pretty simple and straightforward. I can now delete all these values that I got here, and I still have this final value here, and it's pretty impressive actually to get this value by saving all these numbers. So you might feel that's not that important. I just saved 2 or 3 seconds, just 2 steps. But let's see this example where you'll feel exactly why it's important in a case like this. So these values that you see here is the constants for calculating the CP for these components. So if you recall in the energy balance video, We discussed before that we are interested in calculating the CP from these constants to get the enthalpy and then do all the energy balance calculations. And the equation was the CP equals A plus BT plus CT square and then DT power 4 or power 3. And the A enthalpy is the integration of Cp dt. So we did the integration, and then the final form was A multiplied by T minus T reference, and then B over 2 T square minus T reference square. So it's already discussed before. Let's say we have these 5 components. We already have the values for the constants for each one of them. And now we wanna calculate the enthalpy for these components. At this temperature T1, which is 370 Kelvin, and the reference temperature is 25 Celsius or 298 Kelvin. So I wrote the equation here. So this is A multiplied by T minus T reference, B over 2 T minus T reference square, and so on and so forth. We already have dollar signs here on the T and T reference so that we can drag the formula. So when I go ahead and drag it here, we calculate the enthalpy for them, and you have here, this is actually the specific enthalpy, which is per mole, and then we have the flow rate as mole per second here, and then we want to get the total enthalpy for each component. And of course we're assuming ideal gas, so the total enthalpy will be the summation of all the enthalpies, and this is the final value of the enthalpy of the stream. So again, it's not difficult, just to write the formula correctly, and then everything will be a piece of cake. But let's say that I have these values for the enthalpy and or for the temperature, and I want to calculate the enthalpies for the 3 values, and you might need more, but let's say we have only 3. So if you have only these 3 values and you want to calculate the enthalpy for all of them, then you have to make 3 of these tables, one for each temperature, and for each one you need to calculate it based on the required temperature. So you need to, let's see how many cells are these. These are 18 cells. By the way, if you want to know what's the number of cells, it says count 18 here, so you don't need to count them by yourself. It's already counted here, and it gives you the average and the summation by itself. So it's pretty cool. So if you want to get the sum of these, it's already here, which is this same value here, and this is the average. And it says it's 5 cells because I already highlighted 5 cells. Anyway, so let's go back. So you want to make out of these, let's say these are 15 cells. You will make 3 or 2 more of these. So you'll have 30 more cells just to calculate 2 values. And let's see how we can do this using the matrix or the array. So I'll just copy the formula here, so I don't need to rewrite it again, and then see what we can do. So let's first do it the same way we did before. I'll calculate it for each cell of them, and then get the sum. And what you only need to expand this selection. You don't need to do anything else. The formulas are set and everything is good to go, and then Control Shift and Enter, and these are the values, exactly the same values for specific enthalpy, and you're ready to go. The next step is to get the sum of the multiplication, so I can do it here, equal to the sum of the multiplication of these values by the flow rate, and then it's already the same value. So you see, instead of having 3 rows, we did this in only one single row, which is good, but we can be even more efficient by doing the same thing like we did last time. So I'll type it here. This is the same formula. I did nothing different. The only difference that I'm gonna do is to calculate the sum, and I'll do brackets over the enthalpy calculation for the specific enthalpy, so that you make sure that you do not multiply the last term in the enthalpy with the flow rate, just to make sure it's safe. You don't do any mistake in the formula. And then this is what you're gonna get. Voila, this is the temperature. So I'll zoom out so you can see the formula easier. Yeah, here it is. So I did the brackets here and here, so that this is the total enthalpy, or the specific enthalpy is already between brackets. So this multiplication sign is not gonna be multiplying this by the last term, just to prevent any mistake in the calculations, because I did it before without the brackets and it didn't work. It did another number. So just want to give a heads up about this. So this is pretty cool actually. I calculated this cell without even the need of oops, there's something wrong here. Oh, I forgot to press Ctrl Shift and Enter, so this is why. So I calculated this cell here, and I saved this column, or this row and this row. I just used this because of course it's a flow rate, so I'll put it here so I prevent any mistake in the calculations or the counting the number of cells that we need to do the calculation. But for our case here, we need 10 cells to calculate this number, and we did this in single cell. And let's see if we want to calculate. I put this here in the same column for corresponding to 370, and if I want to do the calculations for the 400 instead of the 370. So this will require a simple tweak to the equation, and actually it's tweaked to the dollar sign. So you want to make sure that when you drag it to the right, that these values are not going to be dragged with you. So all the values from B6 to B10 needs to have a dollar sign, so that you keep them in place. So I'll put a dollar sign here, B7, and then B8 and B9 and B10. So whenever I do the dragging, it's not gonna matter. The next thing is to remove the dollar sign from the temperature. So I want it to be dragged with the formula. So I'll move this dollar sign from here, this dollar sign from here for all the C2s, and of course the reference temperature should be always constant, so it doesn't need to do any edits to it. So I'll oops, I didn't do Control Shift and Enter. Don't forget it. I forget it a lot. So you have the value now, and it should be ready. So when you drag it to the right, you get the values for the enthalpy at 400 and 500 degrees Kelvin. So when you drag it, actually it keeps the array thing because it's a single cell, so it's not a big deal. So you have here this bracket and this bracket here to tell you that it's an array calculation. Just need to make sure that it's calculating right. So I'll open the formula. As you see, they all are calculated from the right A, B, C, and D. It didn't move the selection or the dragging because of the dollar signs. The T reference is still the same. The T2 is now corresponding to it. One last check. We know that this value is calculated from this temperature, because these enthalpies are all calculated from this temperature. So I'll double check by changing the temperature to the 400 and 450 and check if these values are the same value that we are gonna get here. So it's saying 4.63, which is 4.63, and if you try 450, it's gonna say 7.08. So actually, this is awesome. We now can get rid of all these values or all these rows. And simply say I have all the constants, I have the temperatures and the reference temperature, and using one formula I'm able to calculate the enthalpy at any temperature that I'm interested in. If I want 100 temperatures, I can type the temperatures, drag this formula here. You don't need to do any enthalpy for a specific component unless you are interested in it. But in this case, I want the stream enthalpy, and it's not of interest to have the specific component enthalpy. So it's gonna be really helpful. So I hope you like it, and see you in the next video, inshallah. Bye bye.